Okay, so here I am once more, looking at Paul's online notes, which are fantastic. Absolutely fantastic. Okay, so today I'm looking at graphing. So we are to construct a table of at least 4 ordered pairs of points on the graph of the equation and use the ordered pairs from the table to sketch the graph of the equation. So what does that mean? That means create an XY table like this here. 0, 1, 2, 3, and 0, 1, 2, and 3 will do as X values. Then just put them inside the function or inside here. So where X is, put in 0, and then you will obtain the Y value. So 3 times 0 plus 4, which makes 4. 3 times 1 plus 4, which makes 7. And continue like this. So 3 times 2 plus 4 is 10. 3 times 3 plus 4 is 13. And those are your points. Those are your points. 0, 4, 1, 7, 2, 10, 3, 13. This is a straight line graph that has a y-intercept of 4 and an x-intercept of, no, what would that be? The x-intercept 3. But, you know, we're asked to sketch the graph of the equation. Now, how can you, when you sketch the graph of an equation using points, you should use precise graphs. You should use precise graphs to precisely plot the points. We already know this is a straight line equation, and so we would just really be connecting these 4 dots together. So because I don't have a piece of graphing paper on the screen, I'm not going to do that right now, just in this instance. But of course, if it becomes a more fundamental part of what we're asked to do, I will get some ready. But in this instance, it's quite fine. Again, we use 0, 1, 2, and 3. But, you know, maybe that's not actually the best idea. Maybe that's not the best idea because this, I already know ahead of time that it's going to roughly look like this upside down U opening downwards like that. Axis like that. Okay, so if I just 2 and 3, I'm just going to get one side of that curve. And I would like points on both sides of the curve, right? Use -2, -1, 1 and 2 for my points. So here I go. If I put -2 in there, I'm going to get 1 minus 4, which is -3. I'm going to get 1 minus 1, which is 0. And then these will be totally identical. So these are the points that we would actually end up plotting in the end. And they should be connected with a continuous curve like that. and they would appear there, and there, and there, and there. And it's important to note that you don't connect them with a ruler or straight edge by any means at all. Okay, for this one here, I will do just a little thumb sketch because I feel uncomfortable like not doing anything for it. So it would have a point there, and there, and there, and there, and it would be quite a steep line. Wait, no, that's actually mistaken. Oops, glad I caught myself. Okay, it would go through 0,4, and yeah, it would still be steep. Like that. Okay, right, cool. So now onto the third one. This is 2 plus the square root of x, so I will not put in any negative values of x. Instead, I will start from 0 and then put in 1, 4, and 9. And the specific and special reason is, I think you know, because I take the square root of a square number and it gives me back a nice whole number, which is nice. So 2 plus the square root of 0 is 2. 2 plus the square root of 1 is 3. 2 plus the square root of 4 is 5. Wait, is 4, beg your pardon. And then 2 plus the square root of 9 is 5. So I will end up plotting 0, 2, 1, 3, 4, 4, and 9, 5. And what will this graph vaguely look like? It will look like half of a parabola opening up towards the right. So sort of vaguely like this. The other half that would be there is like that, but it's not there in this case. And so there's 0, 2, 1, 3, 4, 4, and 9, well, hold on, that's completely wrong. Sorry, beg your pardon. 0, 2. Wait, am I even doing this right? Oh my goodness me. Okay, not even paying attention. Okay, 0, 2. So it actually starts up here. Yeah, I got it mixed up in my mind. So it's that half of the parabola but translated upwards, not to the right. It was wrong of me to say it went to the right. Okay, so there it is, 0, 2, 1, 3, 4, 4, and 9, 5. Something like that. That's what it will. Now for the next, want to check those three, don't we? Okay, we'll let it load. For the next problems, determine the x-intercepts and y-intercepts for the equation and do not sketch the graph. All right. So for 3x takes 7y equals 10, to determine the x-intercept. Now, in this case, I mean, it's a line, and so there are special techniques, but I want to say something in general. To find the x-intercept or the y-intercept, what you will be doing is plugging in 0 where x and y are. And the reason being, when it crosses the x-axis or the y-axis, one of the coordinates will be 0, right? And your job is to find the other one. Okay? So when the curve, whether it's a straight line or a curve, crosses the x-axis, the x coordinate of where it beg your pardon, the y coordinate of where it crosses the x-axis will be 0. Okay, so find x-intercepts. Just plug in 0 where y is, like so. So what is this saying? This is saying that 3x minus 0 is equal to 10. In other words, 3x is equal to 10. And when we solve this and we obtain a 3, that's telling us that it crosses the x-axis at the value. Okay, so the x-intercept, to be totally crystal clear, is 10 over 3, comma 0. This site has some loading issues. Okay. Now, to find the y-intercept, it's a parallel process. And what you have to think is, okay, when it crosses the y-axis, logically, when it crosses the y-axis, the x-coordinate of that point should be 0, right? I'm not going to the right or to the left by any amount. I'm just going up or down the y-axis. And so the x-coordinate should be 0. So what you do is you plug in 0 where x is, and then work out the y-coordinate from that. So there we go. Putting in 0 where x is, minus 7y is equal to 10. And then this is saying 0 minus 7y equals 10, or minus 7y equals 10. And then solving for y is equal to minus 10 over 7. So to be crystal clear, the y-intercept is 0, comma, minus 10 over 7, just like that. Okay, that's problem 4. This is a quadratic. It's a quadratic. And you have to learn special things about all of these curves, and you can't just do that technique every single time, or it'll take you ages. You know that it's a quadratic, it's a parabola that opens up downwards, but it's going to be translated upwards by 6 units, exactly 6 units. So I expect that it's going to cross the y-axis at 6 and the x-axis version. But we can just do it one more time. So if I plug in 0 where y is, I get 0 equals 6 minus x squared. So x squared is equal to 6. So x is equal to plus or minus the square root of 6. So here are the x-intercepts. The first one is going to be negative root 6 comma 0. And the second one is going to be come on, this is taking forever. We're not going to be able to check our work. As for where it crosses the y-axis, just plug in 0 for x, and you'll see that y is equal to 6. Y is equal to 6. So 0, comma 6. Now for short, you can just say x dash int like that, and then y dash int like that. Now this is taking. Okay, so that's my connection is fine. I guess it's just this site. It's not very good at loading. Now for question 6 right here. Okay, so this is a quadratic, and it's a factorizable quadratic. So we're going to say y is equal to x plus 7 times x minus 1. Now, all right, so this site is not going to load, but okay, it's streaming fine. But I need it to load to check work. So I'm going to read and then check that I'm back. And now can it load? I guess not. I guess we're kind of stuck with this page for now. Anyway, so what you do is you factorize that into x plus 7 times x minus 1. And then you know that it crosses the x-axis at minus 7 and 1. The x-intercepts are minus 7 and 1. And intercept, well, just plug in 0 where x is, and you'll see that y is equal to negative 7. And so we can just say negative 7. This is like an ultra compact way of doing it. But if you want to be proper, then you would say negative 7, 0, 1, 0, 0, negative 7. Yeah. All right, so for this one, okay, exactly as we found. That's good. We'll open up the next two now that it's working. And it's exactly as we found. Total agreement. And it's exactly as we found once again. Okay. Now for problem 7. Y is equal to x squared plus 10. So I already know ahead of time, because I've done this quite a bit, that this will be a parabola that's floating above the x-axis. In other words, it's going to vaguely look like this. They tell us not to sketch the graph, but I'm just showing you what it's going to look like. So obviously it's not going to cross the x-axis. So when it comes to x-intercepts, I just say none. As for the y-intercept, sticking in 0 for x, we of course obtain that it's 10. Next up, this one right here, x squared at 6x at 58. You should be able to just say there's no pair of numbers which I can combine by addition in any way that are factors of 58. In fact, there's just 2 and 29, so clearly not. So, what's it going to look like then? I mean, it's not the maker of the website's fault, but it just does not load. So I should like load the answers ahead of time next time. Perhaps it's the stream that's interfering as well. Anyway, so you should find the roots of this. Well, let's see. If I do b squared minus 4ac, that's the discriminant. So 36 minus 4 times 58. This will be floating above the x-axis as well. So we need not labor with finding the x-intercepts. We can just say that there are none at all. And as for the y-intercept, it would be 58 by similar reasoning into question 7. Now for this one, this is in completed square form or vertex form, I guess you could call it. So Yeah. Now, what you can do, that's sort of what you may be thinking, but you want to find the x-axis intercepts. All right, so for the y-intercept, that's something we can just immediately do by just plugging in 0. We see that we get 3 squared minus 8, which is equal to 1. So there's the y-intercept, just 1. Now for the x-intercept, it's tempting to just square it out and subtract 8 and then try to factorize or plug in the formula and just think about it in that way. But instead, I want to think about if this form actually tells you something inherently. If I set y equal to 0, I would move the 8 to the other side, so again equal to x add 3 all squared. And then I square root 8 to get plus or minus 2 root 2, and then subtract 3 from that. And then I'll get the x-axis intercepts. So the x-intercepts are -3 plus or minus 2 root 2. There you go. Okay, so we actually got some successful loading here. All right. So, yes, okay, you got complex solutions, and so that does mean no intercepts. Yes, that's right. No x-intercepts. The y-intercept is 10, so that is correct. Oh, we'll load this one as well. Okay. No x-intercepts. That's good. And for 58, so we're in agreement. -3 minus the square root of 8, which is 2 root 2. So that's nice. So we got... All right. Now, well, now what? Now the next section. The next section is lines. So this was just called graphing. So I'll just save it on my desktop as graphing. And yeah, let's work on lines. Okay, so get the solutions ready as well. Better get the first 5 because you never know. 1 and 2, determine the slope of the line containing the 2 points and sketch the graph of the line. Okay. So, to determine the slope of the line containing the 2 points, first you need to find the gradient. And you can do that with 2 points by dividing change in the y coordinates by the change in the x coordinates. So in other words, the gradient whose symbol is m equal to, in this case, 10 minus 4 over 1 minus 2, so 1 plus 2, which is of course equal to 6 over 3, which is 2. There's the gradient. Now, with that information, we know that the line will look like this: y equals 2x plus c. We know it will look like that. But we don't know what the y-axis intercept is. And the way to find it is to just pick up the coordinates of one of these points that you know is on the line and put them in the appropriate places. Put 1 where x is and 10 where y is. Because the whole point of this equation is to tell you how the x and y coordinates relate to each other in the first place. Okay, the y coordinate of every single point is double the x coordinate plus some number, okay, which is the number we're trying to find out right now. So 10 is equal to 2 times 1 plus c. And of course, now we can easily notice that c is 8. So the slope of the line containing the two, and this is enough information to get us going of the graph. What you would do is you would plot 8 on there, and if you had grid or graph paper, square paper, you would make sure that it has every 1 unit you go to the right, 2 units up. In this case, I'm going to say where it crosses the y-axis and where it crosses the x-axis. It crosses the x-axis at -4, right there. And then it will be the straight line that passes, the unique straight line that passes through those points, which is something a little bit like that. Okay, problem 2 is basically the same. So I do it a bit faster this time. Gradient, -7, -2, so -9 over 14. Then to get the y-intercept, y equals -3 over 2 x plus c, and pick up the easy looking points. So I'm going to go with 8 and 2. So I'm going to put a 2 there, an 8 there, and then work out c correspondingly. -3 over 2 multiplied by 8 is -12, so 14. You will have this as your equation, the equation of your line, -3 over 2x plus 14. And what does that mean? That means that it's going to pan the x-axis, where y is, bring that 14 over, so you have -14 equals -3 over 2x, and multiply both sides by -2 over 3. So we get 28 over 3, which is over here somewhere. 28 over 3, well, that's about 9 1/3, so something like that. And it will be the unique line that is sloping downwards and passing through those 2 points precisely. Okay, now let's check those 2 answers. Okay, so we are in total agreement about that. That's good. This one. All right, so we are in total agreement about that, and that's good. Now for problems 3 to 5, write down the equation of the line that passes through the 2 points and give your answer in point slope form and slope intercept form. That's point slope form. I don't know. I know what slope intercept form is, though. It's the one that I've been showing you. And I also know what standard form is, but slope form is, so I guess I'm going to learn something. So for problem 3, let's see. 10 minus 4 over 1 minus 2, so 1 plus 2. So we end up with 6 over 3, which is 2. And, excuse me, this is absolutely identical, problems 3 and 4 to 1 and 2. Okay, so yeah, we get y is equal to 2x, add 8. Here's the 3 dots that symbolize my realization. Y is equal to 2x plus 8. Now, I'm curious what slope in point slope form is. That right there is slope intercept form. So we're about to find out. Okay, so there's slope intercept form. And we'll give both possible answers for point slope form. So there's the first one. I see. Interesting. All right. And there's the second one. Kind of interesting. I've never seen that before. So what you're telling me is that if you have the point A comma B and it's on the line, then what you do is you do y equal to B plus M times X minus A, I suppose. I mean, that looks like y minus y1 equals m2 minus m1. Like minus y1 equals m, open brackets, x minus x1. So I guess I have seen that before, but I didn't realize that there was a dedicated name for that. So, interesting. All right. I want to see if that is that actually standard, or is this something that he's making up? Yeah, look, the way that I phrased it is more standard. Yes, it's duplicated on that page and that page and that page and on many other pages. So I'm afraid, sorry, Paul, but I'm going to have to go with what's more standard. So, okay. So we'll try now on question 4. So we already know ahead of time that y minus 3 over 2x plus 14 y equals minus 3 over 2x plus 14 is the slope-intercept form. I love it when names are like this, where the ingredients are all packed into the name, and they're even in order, slope, intercept, just like that. And now for point slope form, the 2-point slope forms. So following the standard that most people would do, y minus y1 equals m x minus x1. There's the first one. Here's the second one. Y plus 7 equals minus 3 over 2, x minus 14. And now to do it with the fifth one. Okay, so the slope, minus 20, minus 8, minus 28. Minus 1, minus 4 is minus 1 plus 4, which is 3. So there's the slope for you. And now we want the y-axis intercept. So we just say y equals minus 28 over 3, x plus c. We pick up our y value of 8 and our x value of -4, and we work out what c is. So 8 right there. -4 right there. And now it's time to work out what c is. So -28 times -4, that would be 112 over 3. And then 8 minus 112 over 3. Well, 112 over 3 is 37 and a third. So 8 minus 37 and a third. That's the same as -29 and a third. So I believe that slope-intercept form in this case is as follows. Now for point-slope form, let's see. Okay, using the first point, y minus 8 equals minus 28 over 3, x plus 4. And for the second one, y plus 20 equals negative 28 over 3, x plus 1. And now we check. Everything must be checked. Okay, wait. Oh, good. Phew. So I was got it completely wrong then. Like colossally wrong. Okay. So, minus 29 and a third. Okay. All right. We're in agreement. They just did it as that rational number instead. And that looks fine for the point slope form as well. All right. Now, problems 6 and 7. Problem 6 and 7, determine the slope of the line and sketch the graph of the line. Okay, so I just need to rearrange it into the form y equals mx plus c, which is slope-intercept form. So what I'm going to do is subtract x from both sides, and then divide both sides by 4. And there you go. So they asked me for the slope, so I'll give it to them. It's -1/4, which means for every 1 unit you go to the right, go 4 units down. No, that's completely wrong. Beg your pardon. For every 4 units you go to the right, go 1 unit down. It's got to be a gentle slope downwards. And now they want to sketch of the line. So I don't have the graph paper, as you know. But you always make an attempt of some kind, and you get better with each attempt, and that's how it works. Notice here I'm doing my axes with a straight line now, see? Always just a little bit better every single time. So -1/4, so it's going to pass through 2. We know that for sure. And where will it cross the x-axis? Well, I'll set y equal to 0. I'll bring the 2 over, so -2 equals -1/4x. And then I'll times both sides by -4. So 8 is equal to x. So it passes through 8. But I could also have worked that out using the recipe that I stated earlier about how the slope actually works in the first place. It goes 4 units to the right and 1 unit down. So it stands to reason I would have a triangle here that's 2 units high and 8 units wide. Now, okay, connecting this by eye like that is kind of a nightmare. So what I'm going to do is I'm going to do that. And then that. And that's it. That's how you do it. Okay, so problem 7 is more or less the same. And it says 5x take 2y equals 6. So I rearrange it into slope-intercept form. So I'm going to have 2y is equal to 5x minus 6. And then I'm going to divide both sides by 2. And there you go. And they asked me for the slope. And there it is. And now we graph it. Y-axis, x-axis. Okay, so what does a slope of 5/2 mean? That means that it's going to be quite steep. And for every 2 units that you go to the right, you must go 5 units up. Change in y over the change in x, otherwise known as the rise over the run. The rise is 5 units and the run is 2 units. It's going to pass through -3. And I set y equal to 0, move the -3 over, so I get 3 equals 5/2x. And then I multiply both sides by 2/5. And 3 times 2/5 is 6/5. So it passes through 1 and 1/5. 1 and 1/5, which is about there. And then I connect them up. And be sure to mark out that point that you just worked out. 6/5, make it clearer. There. Okay, and now we check. We check that our work was correct. And that's true. And that's accurate. And that's true. And that is accurate, yes. Next up, for problems 8 and 9, determine if the 2 given lines are parallel, perpendicular, or neither. 2 lines are parallel if their slopes are equal. 2 lines are perpendicular if the slope of the first line is m and the slope of the second line is -1/m, the negative reciprocal. For example, say if I have a line with a slope of 5, then a line with a slope of -1/5 would be perpendicular to it. And say if I have a line with a slope of 5/7, then a line with a slope of -7/5 would be perpendicular to it. So in this case, This is in slope-intercept form, and this is in standard form. So right now I cannot compare them to one another. I need them both to be in the same form. I'm going to convert this into slope-intercept form because then I can just read off the slope easily. So 3y is equal to negative 7x minus 10. And then divide both sides by 3. So y equals negative 7 over 3, x minus 10 over 3. And as you can clearly see, 3 over 7 and negative 7 over 3 are their slopes, and therefore they are perpendicular. And we can articulate this, or rather write it on a page, by saying m1 is 3 over 7, and m2 is negative 7 over 3. So they're perpendicular. Perp is an acceptable abbreviation for perpendicular. And the symbol for it is an upside down T, like that, because it kind of looks like two perpendicular lines. Next up, 8x take y equals 2. And then we have a line containing 2 points. So we need to extract the gradient of both of these lines. So I'm going to begin with the first one. What I'm going to do is I'll just write it out clearly and rearrange it. So m1, the gradient of the first line, is equal to 8. And now for the second line, if it's passing through the points, and you can write L1 here like that, and L2 here like that, organizing your thinking. For the second line, it passes through 1, 3 and 2, negative 4. So to find the gradient, I need to find the change in y over the change in x. So minus 4 minus 3 is the change in y. And 2 minus 1 is the change in x. And so that is negative 7 over 1, or just negative 7. And that's m2. So neither. They don't pass either condition. Now, that's problems 8 and 9 done. For problem 10, find the equation of the line through negative 7, 2. That's a little bit ungrammatical, a little bit. Find the equation of the line that goes through negative 7, 2 and is parallel to the line 3x minus 14y equals 4. So first, find the slope of 3x take 14y equals 4. And so just put it in slope-intercept form. And when you do that, you'll get 14y equals 3x minus 4. And divide both sides by 14. So m is 3/14. And then you need to find the line that has that gradient right there and passes through negative 7, 2. So the candidate line we know we'll have this form. But what we need to work out is the y-axis intercept. And so what we do is we just plug in -7 and 2. So 2 right there, and -7 right there where x is, and then plus c. So 3/14 times -7 is -3/2, and 2 plus 3/2 is 3.5. So c is 3.5, or 10/2. No, beg your pardon. 3.5 is 7/2. And now problem 11. Find the equation of the line through -7, 2, and it's perpendicular to 3x -14 minus 14y equals 4. So beneficially, we can just use what we've found before and build upon it. So just turn this into the negative reciprocal. Just like that. And know that it has to pass through -7, 2. So it will have the form like that. And stick into y's and stick in -7 where x is. And now -14 times -7 is 98, and 98/3 is 32 2/3. And subtract that from 2, and you get -30 1/3. So c is -30 1/3. So the final answer is -14/3x minus 30 1/3. Although I guess they want it in like rational number form. So -91/3. And now check everything. Everything must be checked. Everything. So they're in agreement, perpendicular on the first one. And they're in agreement, neither, for problem 9. And do they agree with me? Oh, yes, they do. Okay. But they did a bunch of intermediary steps. Y is equal to 3/14x plus 7/2. That is correct. Now, y is equal to -14/3x minus, should be 92. Okay, where did I falter? Just off by 1/3. Let's see. Okay, so -14 times -7 is indeed 98. And 98/3 is 32 2/3. Beg your pardon. So I must have dropped that third at some point. And there we go. Now it has been corrected. So it's all good. So I will save it to my desktop as lines. And next, oh man, look what's coming next. Circles. Most interesting. But I guess I should save it for another time. Okay, be well, be well.